Now for another definition. We're going to call the value R, when we're looking at our formula, the growth rate. It is actually going to be the percentage growth, or decay. In our previous example, the R would have been the 0.3, the percentage that the money was earning each year. If the situation is growth, then what happens is our formula that had the f at t was a times b to the t would actually tell us that b is 1 plus the rate, and if the situation is decay, then b is going to be 1 minus the rate. Now, notice here we've used two very similar phrases, and this gets very confusing. We've used growth rate and growth factor. The growth rate is the percent. It's the percent growth or decay. This number, the growth rate, will always be a number for our purposes between 0 and 1. It could be a number bigger than 1, but for right now, let's say it's going to be between 0 and 1. The growth factor is 1 plus r for growth and 1 minus r for decay. Be very, very, very careful not to confuse these two. Let's take an example where we're going to use both phrases and look at where and how these differ. So suppose we have an example. I have several different parts, several different sub-pieces here. Suppose we have an account that grows at a rate of 4.5% per year with an initial deposit of $500. What I'd like to do is determine the equation modeling the situation. Well, notice I was given the percent, so the percent is my R. It's growing, so I'm going to use B equals 1 plus R. So it's going to be 1 plus, and 4.5% as a decimal is 0.045. So our B is going to be 1.045. And now if we substitute in the initial value in our B, we have 500, Q equals 500 multiplied by the quantity 1.045 to the T. Part B. Suppose an account loses value at a rate of 5% per year with an initial deposit of $1,000. I'd like to determine the equation, modeling the situation. Well, again, this time it's decay. So instead of doing B equals 1 plus R, we do B equals 1 minus R. And so we would do 1 minus 5% as a decimal, which is 0.05. When we do the math, we get 0.95. Now substituting in our initial value and our B, we get Q equals 1,000 multiplied by the quantity 0.95 to the T. Part C, suppose I knew B is 1.23. What's the value of R? Well, since we're greater than 1, B is going to be 1 plus R. So if I do just a little quick algebraic equation, that tells me that 1.23 is 1 plus R, so R has to be 0.23, or 23%. We have a growth situation. And lastly, if B is 0.80, what's the value of R? Well, I notice that B is between 0 and 1, so this must be decay. So the formula we use here is B equals 1 minus R. So 0.80 equals 1 minus R. And if I do the math, I learn that R is 0.20, or 20% decay. So this is a decay, but and the rate that we are decaying is 20%.